So I was just having a quick think about the Navier-Stokes theorem and whether or not singularities could exist as solutions to the Navier-Stokes theorem. Um, I suspect they probably can be solutions to the Navier-Stokes theorem, and I suspect that in fluid dynamics you probably can have singularities forming in different regions of space. For instance, I was working on this concept of a warp drive. That's what I'm doing at the moment, one of the things I'm doing. Um, Working on that concept whereby you have a fusion combustion chamber surrounded or held in place with magnetic fields. You create a rough Delaval nozzle sort of shape and then channel those fused particles through a linear particle accelerator out of the back of the spacecraft. And I suspect you would have singularities forming in those under those pressures and those densities of, well, matter and at those sorts of energies. So it would be a kind of Kugelblitz engine, also in a sense, since you'd be utilizing the energetic potential of tiny black holes, and you would have tiny microscopic black holes forming, collapsing matter collapsing into singularities, and these singularities would evaporate very, very quickly. So they'd release photons in that process. So really, if you can drive all that out the back of a spacecraft, you end up generating an incredible amount of thrust, which is really the sort of way in which we need to be utilizing, I think, nuclear fusion in terms of propulsion. Since we're kind of thinking at present about using kind of rocket engine or jet engine type setup or direct fusion drive setup to propel a spacecraft. I would say that that's not the whole picture. That's just that generates some thrust. But I think what we need more like is a ramjet or scramjet style design, or maybe even a pulse jet style design that's incorporating linear accelerators and leading to the creation of singularities and things like that in the exhaust. And then if you do that, the amounts of thrust you'll be generating really will be astronomical, and you might well be able to get to light speed doing that. So that's one hopeful outcome of it. But then, of course, if you get to light speed, you encounter the problem of how do you slow it down exactly? How on earth do you slow this thing down? Do you use some kind of umbrella made out of lead? A parachute? Are we to enter a world of balloons and parachutes in terms of space exploration, space travel? Maybe thinking about how to harness solar winds and things like that with big balloon structures, which I'd love to see up there. An elegant age of space travel with sailing and so on. I think it could be beautiful. But I mean, yeah, that's an idea that a lot of people have played with, solar sailors and so on. And I don't think it's ever really been tested yet. I think it should be tested. I think it deserves to be tested. Or did it get tested positively once? I can't remember. Anyway, so that's what I'm thinking in terms of like Navier-Stokes singularities. I think it has applicability to this issue of the warp drive, and that's why I'm thinking about this now. But I suspect singularities do exist in nature. I suspect singularities form very often, in fact. I suspect they form with the collapse of any quantum particle at a very minute level. I suspect also like the Higgs detection in the ATLAS and CMS detectors of the Large Hadron Collider. Those were probably also just singularities forming, naked singularities, which I think is a very exciting idea and kind of reframes what the Higgs field is and what the Higgs particle is. Since what they're creating is like, a totally gravitational entity in a sense. And bosonic in character, sure, but not a fundamental boson. A boson that very quickly decomposes into 2 gamma ray photons. So there's nothing fundamental about the Higgs at all. It doesn't really belong in the standard model. It's a composite particle. it's one level above being fundamental, I think. That's my opinion of the Higgs boson. Anyway, I think I've rambled on enough. Thank you very much for watching. I love you lots. See you soon.